Alright, so this question says, assume that a set of scores is normally distributed with a 105. Now what I tell you, whenever you get one that says mean and standard deviation, what do? Draw a picture, exactly. That's the first thing you do, so do that. Draw a picture. And then on this problem, what kind of rule are you going to have to remember? What's it called? The empirical rule. And that's on page 367 through whatever y'all said that day. We've only said it like 3 or 4 times. 367 through 371 or something like that. I don't know where it is. All right. Bring it down, please. And 100, 105, 110, 95, and 90. Everybody with me? Now, remember me telling you that this is pretty much your fuel indicator? Read from left to right. This is 25%, and this is what? And this is what? 75, and this is full over here. So, at halfway in the center, that 100 represents what? 50%. Greater than 105. Well, 105 is right here. So you got to get to your handy dandy empirical rule. And this is 34. This is 34. This is 2.5. And this is 2.5. Thank you. Now, if you want to find the numbers that are greater than 105, what do you do? And that's 15%. Or 16, what is it? 16%. And that's where you get that. Now, what percentage is between 90 and 105? Well, what's 34 and 34? And what's 68 plus 13.5? Thank you. So that would be 81.5. Her answer is wrong. That's the correct answer. Huh? Well, it says between 90 and 105. So what do you do with these three numbers?
Book and thing explains it, like you have to add, you have to find this number and subtract
I never noticed that. I didn't know how they.
When you go to give you an example of how we solve this, it's horrible.
Because if I wrote a book, it wouldn't be. That's mine. You want to be proper, or you want to understand how to do it. that's my. I'm sorry. I'm trying to. Guys cannot do this. Okay. Just can't do two things at the same time. Find the percentage. I'm going to get you all that. I don't even know if there's questions left. That's what they call the empirical rule right there. They call it the 68, 95, 99.7 rule. This book is stupid. I'm sorry, it is stupid. I'm sorry, it's stupid. Because that's ridiculous. It's called the empirical rule in many books, and they just say, okay, we're not going to call it the empirical rule, we're going to call it the 68, 95, 99.7. This right here is saying use the empirical rule to get your percentages. Is what that's saying. But I can see why you're confused. I think we'll just leave that alone. All right, let's do another help. All right, let's do another homework problem.
It's pretty high on the Charles.
It's pretty what?
It's pretty high on the Charles.
Pretty what?
Pretty high on.
I don't know.
Especially at night.
Okay. Oh, because it's Pi Day?
Yes, it's free pie night. It's our
No, it's Pi Day. Today's National Pi Day, isn't it?
I know, Wednesdays. No, that's in March. Yeah, that's the
Oh. Okay. I don't know when it is.
free pie Wednesday and Wednesday.
No comment. All right, Miss Jordan. This is 6C 21-4. 6C 21-4. All right, try this one for those that are listening. Use the normal distribution IQ scores. Find the z-score using. Okay, let me just find the z-score using 105 and 15 for 75, and then tell me the percentage by using the table. They're all going out of business, turned into Amazons.
Not the 28 one yet, but if you can call them and see if they have any of those memory cards, they're like 30 to 40%.
They just bought me one. 64 gigabyte. It was $20 at Best Buy. Yeah, I appreciate it. The 64 one is right here, and the 32 is in there. So I already downloaded them. I'm already recording. Yeah, man. All I got to do is ask, and they'll give it to me. And I have a feeling she's going to want me to present at the conference before long. That's all right. What do? Draw what? Draw a picture first. $105, $120, $135. 105 minus 15 is what? 90? Help me.
Yes.
And then 75. Now, the question says, greater was greater than. Greater means 1 minus left-hand one side, because greater is the right-hand side. And the right-hand side is 1 minus left-hand side. Capiche? All right. So that's just something you need to remember. You need to remember that, but you'll see it when you do your drawing. So where is 75? Right here. So we need to find those purple marks right there. But the table gives us what? The table gives us the left-hand side. So if the table gives us the left-hand side, how are we going to find the right-hand side? 1 minus the left-hand side, which the left-hand side is the red marks. So that's what the table gives us. So, look at your handy-dandy table. We got to turn it into a z-score first, because you can't find these in your table. So we got to change these to a z-score. The z-score of 0 is here. That's 0. That's 1. That's 2. That's -1 and -2. That's what it's going to come out to be. Well, let's check 75. So here we go. 75 minus 105 over 15. And what's 30 divided by 15? -30 divided by 15. -2, and that's your z-score. -2 is that right there. So, if we go to our handy-dandy table, and look up negative what? -2. -2 gives us a dang old percentage of what? Stand when they do that. Yeah, 2.28. In the 120 books, in all probability books, they do 4 decimal places. It's 0.0228. Alright? And then when you get to this book basically dummies it down for y'all. I hate it. I'm sorry. That's what they do. What they're saying is that y'all ain't got sense enough to change 4 decimal places into a percentage, so they go ahead and do it for you. And I'm used to seeing in 4 decimal places, and when I see that 2.28, it just messes me up. So it's 0.0228, and if we change 0.0228 to a decimal, it is 2.28. So this red area is 2.28%. And under the curve is 100%. It's one if these were 4 decimal places. Okay, so this is 100 minus left-hand side. So 100 minus 2.28 is dang old 97.72. And that would be blue. So 97.72% is your answer. In other words, 98% of this population has a score above what? 70. And those are test questions. There's about 3 or 4 of those on the test. Correct? I think there are, aren't there? Yeah, Hubert. Thank you, class. What did we get? 90 what? Does it say round 2 decimal places? 97 point what? Dang, oh, we feel good about ourselves. I don't know what I'm doing. Okay. Alright. That's 103. That's this class, isn't it? Yeah. We've already went over that one. 6C21. What's this one? 6C21 is one like that. 6C25/6. 25/6. Alright? That's another test question. A data set is normally distributed with a mean of 270 and standard deviation of 36. That means, okay, draw this. That's what it means. It means draw this. And then after you draw it, convert everything to a z-score and do 378. Okay, convert 378. You don't even need to draw it. I'm sorry. This one you don't even have to draw. You just take 378 minus what? 270. And that's dang old 108. Or 108. And what's 108 divided by 36? And that's your answer. So you might want to make a note about this one. This one is just dang old plug and chug. You don't have to do anything. Plug and chug. 378 minus 270 over 36. Okay? You got that, Mr. DeVoe? I'm worried about you, Mr. DeVoe. I don't get to talk to you very much. Kind of leaving me out. What's up with that? You don't want to talk to me anymore? Or did I say something or what? Huh? Was it the crash that you had? I mean, was it the trauma? Was that it? Alright. I still think you're a good guy, no matter what the class said about you. Next. 6C29A. Feel like I'm doing Miss Jordan's homework.
I got them now after we went over the
That's
test.
okay.
But at first,
Most of the time, I cover the review test. When I review over the test, that answers a lot of questions.
I kept hitting what we saw and it was like confusing.
Well, you did the right thing. When it confuses you, you send me the question. I wish everybody would do that. Find the standard score, blah, 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 blah. 2.6. You don't even have to do anything. Listen, if you can't get this problem right, all you have to do is look at 2.6 right there. Now, they're asking above the mean. Okay, that's it. They just want to find, so it's 99.53. Well, then why are they asking that?
Yeah, I don't know. That's why I was like, what the heck?
It should be asking you for the 99 point.
It will.
Okay, I see why people miss it, because they make it difficult. Standard score is 99.53. Okay, we should get the second part. All right. Remember, what they're trying to get you to see is that the z-score is the number of standard deviations. It's the same thing. It's what they're trying to get you to realize. Nah, I wouldn't put that on the test. I hope I didn't, but if it comes up, I didn't mean for it to. Okay, does that answer? Does anybody have another question that's really bugging you? Miss Raines, I got yours. Right?
Well, this one is on first.
Okay. Let me pull it up right quick. Do you remember what number it was?
I know it was like, it gives you the, I wrote it down. They give you the percentile, they let you find the number.
Okay.
And I got the equation and everything, so you put the number of items in the group on there, but it didn't have the number of items on there.
The first test or the second test you took?
It's the second one.
what number?
It's either 7 or 9. Well, I put 100 for that one, it's supposed to be 9.
Yeah.
I think it's 9.
Do you understand why?
Yeah.
Okay. We did that one in class. Is this the one you're talking about?
Yeah.
Okay, let's do this one. I'll let y'all work on it first. Blow it up a little bit, Anna. The scores for a certain test of intelligence are normally distributed with a mean of 90 and standard deviation of 18. Draw a picture. Find the 90th percentile of the scores. I'm going to give y'all a second to work on it. And give you a hint. You might have to go backwards. In other words, you're not finding the percent. They're giving you the what? The percent, the 90th percentile. That means 90%. That means that under the curve on the left-hand side is 0.9000. Now, I don't think we have done a problem like this, but we've done the other way, and basically you're supposed to go bass backwards. You're supposed to go the opposite way of what we've been doing. Before, we would get the z-score, and you would look up the z-score in that table, and it would give you an area. This time, they're giving you the area, so you got to find that area, change it to, see what the z-score is, and then plug that back into the equation. And the equation that you have to plug it into is x is equal to Oz plus mu. You didn't show us that. Well, you had it. Oh, bring it down a little bit. Z is equal to x minus x bar over standard deviation. Okay? Or x minus mu over sigma. Alright, both of those are the same. Now, I couldn't come up with a fancy phrase with this one, so I'm using this one, okay? And if I solve for x, I get x is equal to Oz plus mu. And that, sorry about that, and that is the formula you use on this one. Dang old loggy. Alright. So instead of using the z bar formula, we're using the derivation of the z bar formula. I don't know what I just said. The z score formula. Now, problem is, you don't have a z-score. So, there's two types of question with these z-score questions. The first one, we've already done. Let me use black because it doesn't show up on the video as well. Let's do this. One, there is given an x, a mu, and standard deviation. Find the probability / percentage / area under the curve. Alright? In other words, the first type question, we've already done a couple of them last time we met. The mean is 20 and the standard deviation is 5. Find the percentile that goes with 26. And plot 26 and you can find the left hand side. change 26 into a z-score, it becomes point whatever. And then you look it up in the table and there's the area under that curve on the left-hand side. And then you find the left-hand side, you find the right-hand side. But in this case, this is like number 2. Given mean and standard deviation and what? The percent. And percent can be written as probability, percent, or area. In other words, they might say the area under the curve is 90% or 90.9. Or they might say the percentage is 90%. Or they might say find the 90th percentile. Or the probability that the probability is 0.9% or 0.9. Any one of those is this type. And you have to, first thing you're going to have to do is you're going to have to find 0.9000 in the table. Now, of course, in the table, y'all have a table in y'all's book. It's probably in there. Y'all just don't know about it. Look in the appendix. Find 90. It's going to say 90% in your book. It's not going to say 0.9 because y'all are too dumb to figure that out. So they change everything in your book to where it's dummy thing. That's why I don't have to do it. So you're going to look for 90%. That's what you're going to look for. It should be in the back of your book. Yeah, please. That was a hint.
You
Or
said
it's
stop.
not. Well, nobody turned to the back of the book. Nobody. Y'all just sat there.
You said stop.
Sorry. Just anywhere, there should be some tables in the back. After the answers, there should be some tables. Look before the answers, see if there's any tables. Okay, look in the section and talk about this over and see this. They may put it in as just a page. What section did this come out of? This is 6C. Look in 6C and see if there's any tables. That's it. What page is that on? Okay, here it is. It's on 390. 390. Turn to page 390. You have a table. I mean, if you have, let me pull it up right quick for all of those losers that didn't bring a book. You know, all you got to do is print it out per section, but I know that's hard work. What chapter are we in? 6? See what page did I say it was? Is that y'all's book? Yeah, there it is. So you're given the percentage. So where do y'all see 90%? 1 point what? 1.3. Well, Hubert, it doesn't say. I know it doesn't say 90%. It says 9.32. I see that. Do you see anything else that says 90? No. Now, you need to check and see which one's closer. This one's 30 cents away from 90, right? 32 cents away from 90. What is this one? 51. So which one's closer? 90.32, Hubert. That's why I picked it. 1.3. So what do you do with that 1.3 now? Plug and chug. So this is going to be x is equal to, what's our sigma? What was it in the original equation? 18. So 18 times 1.3 plus, what was the mean? 90? Somebody crank that out for me. What do you get? The standard deviation. That's what y'all told me it was. Huh? Oh, the whole thing? 113.4. So the score that you're looking for that represents the 90th percentile is 113.4. So either you're going to be given a percentage or you're going to be given X. If you're given X, then you got to find the percentage. If you're given the percentage, you got to find what? X. Does that help? I think that was pretty much all y'all's questions, unless anybody's got anything pushing. All right, well, let's get started on the next unit. The next unit's on page, when does chapter 7 start? What page is it on? For what? 410. Chapter 7 should be talking about probability. Make sure you know the definitions in the green box on page 411. And just leave. I get mad too. Page 411. The scale on page 412, the blue scale, .413, the green box, relative frequency and cumulative frequency is on page 416 and 417. I'll talk about page 417 in just a few minutes. And the complement. Okay, so let's go ahead and get started today. This is chapter 7, unit 2, chapter 7, and what do we go through? 7A through what, Vanna? You still have the piece of paper?
D7A, B, C, and D.
A, B, C. Oh, look and see what is in D. What is the title for D? If somebody's got a book, look at 7D and see what the title is.
Assessing risk.
Okay, Can we, as people, tell the future? Yes or no? No, we cannot. Think about it. If you ever meet somebody that tells you that they can say that they can tell the future, what's the first thing you're gonna ask them? Huh?
How do you prove that?
First thing I'm gonna ask them is, what's the lottery numbers for the Georgia Powerball lottery? And if you get them right, then I will. You ever watch these commercials that come on? Well, they used to. Back in the, I don't know, the late 90s, maybe, the TV was just filled with getadate.com and get a date, 1-800-GET-A-DATE, 1-800 read your fortune, and 1-800 this and 1-800 that. Does anybody remember those? Okay. Well, there was a woman on there one time named Chloe. Was it Chloe? Miss Chloe. And Miss Chloe would get on there and say, I can tell you this, I can tell you you're going to get a job, I can tell you you're going to do this, I can tell you you're going to do that. They strung her up on charges of fraud because you can't tell the future. Why would that possibility? Well, let me give you an example, and if you've had me in 120 before, you've heard this example. Because this happened to me Sunday. I had to go to the big town of Walterboro, pick up a boar. And we went down to Walterboro, and if you don't know what that means, look it up. It's BOAR. And, because I know there's somebody, all right. So we get on this road, because I don't know how my trailer is going to do on the interstate. And I do not like to drive my truck a constant 70 to 80 miles an hour because my truck is not designed to go 70, 80 miles an hour. My truck is designed to pull and not pull that fast. You know what I'm saying? And I don't like doing that because I have worked on engines and I know what engines have to do, and I don't push mine like some idiots do. But anyway, I didn't go the interstate. Interstate, you go down through Columbia, and then you go down this way, and thing old. What did I say it was? Walterboro. Walterboro is right down here. Okay, right kind of between Charleston and Savannah. The guy that I bought the boar from, he sells to all the restaurants in Savannah and all the restaurants in Charleston. What's that silver-haired lady that does all the food? She visits his farm to get his food down there. We have a picture of all of these things. Anyway, we went this way through Augusta. We got on this 2-lane road, kind of like Wild Hog Road. Y'all know where Wild Hog Road is, right? And Wild Hog Road, or in this road that we were on, was like 500 million thousand miles long when you're on it. Because you always get behind the little what? Blue-haired old lady. And how fast is she going? She's going 35 miles an hour. Little blue-haired lady. Okay? And she's going exactly, she's got the cruise set on 35 miles an hour. And this usually happens when you need to go to 8 o'clock class and you're leaving, getting on Wild Hog Road about 15 till 8, and it takes 16 minutes to get the penalty. I've already timed it, I know. Yes, sir. It's take 24 out here, turn right, go across the double bridges. Yeah, go by the bylaw, go across the double bridges, and this is the next right at the red light.
187.
Okay.
It's Wild Hog Road. 187 is down here. We did that's not 187. That's Wild Hog Road.
Wait,
I know
where's the
where
double
I'm
bridges at?
I know. We've always fussed about that. There's 2 187s. One of them's up there,
Okay.
and then there's another one right there at the bottom. And they say it joins. I don't know how they say it
Where
joins.
is it going? I
Huh?
don't know.
It's
No.
right past Follow. It doesn't join
It doesn't join.
I know where the other one is, industrial park,
Yeah,
but where does it join?
it doesn't.
I'm not so why they have to.
Their thinking is since the lake is right here, it probably joined
Joins
at
in the
one
water.
time. It joined at one time.
Oh, yeah.
And I think it did down there, Big Bass Valley. I think that's where it joined, somewhere in there. All right, but anyway, here you are, and you're right behind her trying to aggravate the crap out of her, and you're supposed to be there at 8 o'clock. And up here, kind of opens up a little bit like this, and you see this line here and this line here, and these are people going this way, and this is a right-hand turn, and you get about right here, and you are chomping at the bit. You want to get out from behind this woman. And you start to turn your blinker on, and right before you start to turn your blinker on, you say to yourself, "Put your $1 keep from me." And just as soon as you say that to yourself, what does she do? She turns in. You just foretold the future. Did you foretell the future, or did you just know how your look goes? Which one was it? I'll give you another example. Y'all remind me, y'all remember me telling y'all about if y'all were supposed to come up to my desk and ask me a question, and I started texting like I was, you were talking to me, what that was? I just want to make sure I hear y'all that discussion. All right. That's a warning. Next time it's not going to be so nice. Here is my pasture. And in my pasture, this is about 20 acres. Although my pasture just disappeared. Alright, here's my pasture, and it's about 20 acres. And at this pasture, I got a gate right here. And I got a gate right here. And I got a gate right here. And this gate goes to my holding pen that has the head gate, and it's where I work my cows, and we got a little corral here, and different pens, and I work them and do all my stuff there, and I vaccinate them and stuff like that. Over here I got a pasture. Here I got a pasture that goes this way, and I got pasture over here, pasture here, and pasture here. Okay, so my whole purpose of this little area is not 20 acres, it's about 3 acres. All right? My whole purpose for this area is to get all my cows in here, and I can run them where? Into this little area. So I open this gate up, the cows are over here, about 50 feet over here. And I open this gate. But when I open that gate, I forget that this gate over here is half open. Okay, y'all with me? The cows over here, and I open this gate. I got them all up, and I run them in this gate. Where are they going to go? They're going to go to the gate that I don't want to go. Not because it's the shortest distance. That's just the way it's going to roll. They're going to go straight for that gate. Happens every single time. And they can sense it. They can sense when there's a gate open. I don't know how they can. Now, did I tell the future? Or did I just use a little bit of remembering what happens in the past, my luck, and just that's the way things roll. I'm using a little bit of common sense, a little bit of memory. I'm taking what I've learned in the past and applying it to the same situation, right? All right, that's what probability is. Probability is assigning a number value to a prediction based on several variables such as past mathematics and experience. Now, this is not a mathematical definition. This is a Hubertism. All right? That's what you're doing when you're assigning. You're assigning a weighted value to a prediction. If it's not very strong, it's going to be around 0.1, 0.2. If it's very strong, it's going to be around 0.9. That scale goes from 0 to 1. It said 0 to 1, but I can't write it. 0 to 1. Now, let me go into this a little bit because you got two types of teachers who teach us stats. Uptight and not uptight. And some teachers will have a cow if you say 96% chance. You're supposed to say 0.96. Just tell them. Some people use percentages. Sometimes the uptight ones, they frown upon you using percentages. So just telling you that because some of you may go into Math Science 301 at Clemvine and you walk in and you've got a very uptight statistician. And they eat and drink and live and stuff. Okay? They just sit around and play on their computers with the programs that do this. Okay, that's what they do. And they will sit and talk about stuff all day long and give you a chance. Alright? So you're sitting in 301 and you say, well, I got 50% chance. And they go into cardiac infarction. They do it in front of the chicken on the floor because you said percent. Just remember that if you got an uptight teacher, you just say 0.54 probability or 0.9 probability or 0.3 probability. You don't say 30%. You don't say 45%. Usually that's with chance, not with probability. All right, so 0 is very unlikely. And what do you think 1 is? Likely. And 0.5 is somewhat likely. Whatever you want to put. Maybe. All right. Now, how do you find the probability? Well, there's two types of probability. There is Mayberry probability. And then there is the physical probability. You think these are in your book? No. Look in your book and somebody tell me what page you're on. I told you it's the theoretical and the classic, or they've got two different and the subjective. I don't know what this book calls it. This book probably calls it the chicken wing. Yeah. The theoretical and the relative. Alright. Mayberry probability is the perfect probability. Why do people watch Andy Griffith? Why do people have trading cards in their office with Andy Griffith? Why do people have trivia games? Why is there 3 or 4 trivia games written about Andy Griffith? 3 or 4 trivia books. Why is there a town that you can go to that looks like Mayberry? Why is there so much emphasis put on Mayberry? Huh?
It's a
You're getting there. Perfect. How'd you know that? You must have had a good teacher in the past that told you that. It's modern day what? What's the word that we use for paradise? Utopia. Think about it. Is there a drug problem there? No. There's only one reference to drugs in the whole show, and it's Barney calling it marriage of orange. Okay? There's no crime rate, only bootlegging.
Let's talk about alcohol.
There's what that. That's it. I mean, I'm not talking about illegal drugs. Otis, that's because he's got a swimming pool. But why? It's a perfect place. There's no fighting. There's no cussing. There's no drugs. There's no. Everybody's happy. That's why everybody loves it. Huh? Yeah, he doesn't even carry a gun. Except for 2 episodes. This is perfect probability based on assumptions. What assumptions? Well, the probability of flipping a coin, the probability of getting tails with a coin is what? 0.5. What is the probability of rolling a die, a 4 on a die? 1/6. What's assumed? Well, first of all, it's kind of assumed because how many sides of a quarter are there? 2. And if you flip it, it's not going to land on its side. It's going to land on one of the sides. It's not going to land on the edge and just stand up. If it does, that's the equinox and the egg and stand the egg up and stand the broom up. You done that before? That's weird. That is weird. When you see a broom standing up by itself. Isn't it the equinox that you do that?
You can take any from up to excited.
You can't do that with the egg. And in the equinox, you stand the egg up on its edge, on its top edge, and then after the equinox, they fall down. All right. I have no idea how we got to that, but anyway. What's the probability of a king being picked out of a deck of cards? 52. Now, in order to know that, you got to know that there's 52 cards, and you got to know that there's 4 face cards. If you don't know that, then you're slow. You need to learn the cards. A bunch of questions in here about the deck of cards. So if you're one of these people, I've never even played with deck of cards. Okay, don't tell people that. All right? Because they will take advantage of it. All right, you need to learn it. There's a little. Write this down. Soldier's prayer. That's the best way to learn it. Okay? Huh? Okay. Well, what is physical probability? The physical probability is what actually is done, what actually is attempted. Let's say that I give you a quarter, and I tell you to flip that quarter 100 times and write down the results. That's your physical probability. Now, you might get an average, or you might, I don't know how you do it, but the whole point is, if you flip it 100 times, and you get 49 times, well, not 49, 30 times that it falls on tails, and 70 times it falls on heads, then you've got a 0.3. The probability of your falling on tails is what? 0.3. Well, that does not match what? That. Why? Well, because it's not going to match. What is the only predictable thing that we know? It waits for no man. Time. Okay? Time is the only predictable thing that we cannot what? Predict. we know that we know that 60 seconds from now is going to be exactly 60 seconds from now, and we know that 60 seconds after that is going to be exactly the same. It doesn't slow down. It doesn't speed up. Unfortunately, it doesn't slow down. That's time. Days of the week is time. Time is measured in days, seconds, hours, years. Now, what does that have to, what are we talking about? What does that have to do with this? Well, this is one of the things, probability varies. In a minute, let's go ahead and do an experiment. Or as I texted last night, a sex experiment. I went to the doctor yesterday to get a checkup, and I told her about a problem I was having, and she said, well, here, let me give you one of these, a pack of these pills.
Just stop.
What?
Just stop the story there.
What?
It's funny enough where it's at.
I was going to tell you why I wrote this experiment. And I was telling somebody that the doctor wanted me to go home and try an experiment, take these for a week and see if it worked. And I was typing, and I somehow typed sex experiment, and I got a big kick out of it. But anyway, we're going to try an experiment. Oh, I didn't even think about that. I didn't even think. Oh well, I suck. All right, let's see if I can find the handy dandy virtual. Where is the handy dandy virtual? All right. So somebody give me a number between 1 and 6. 5. All right. Probability of rolling a 5. Well, what is the Mayberry probability of rolling a 5? 1 over 6. And somebody give me that number. What is that? 0.6 will go into 10 one time. 0.1 what? 0.111? I don't know. What is it?
You said 1.6.
0.17, 0.1, 0.2. All right, so let's go ahead and let's roll this die 10 times. Let's see what happens. Where's my output? I just did it. All right. So Mr. Patel is out in Vegas, and Mr. Patel is living in the ditch right now because he just lost all his money because he did not roll a what? So his probability of rolling a 5 is 0% probability, or 0 probability. Okay? Then Mr. Patel finds a $10 bill while he's living in the ditch, just like Charlie and the Chocolate Factory. But instead of going and buying a candy bar, he goes back to the casino and he says what? To the same game. He says, I'm going to bet on what? Or 3. So he bets on 1. So now we go to a probability of 1.
Well, that's where 5 comes in.
It is. Put it all five. Yeah, exactly. Oh, man, you said that.
So back to the ditch, Mr. Patel goes. Then he becomes somebody's, you know, he finds a job doing something, and I was going to try to be funny there, but I'm not. And he gets $10 more. And he comes back. First of all, let's figure the probability of what happened to the 1. Any probability? 0. So he comes back and he says, I got your number now. Let's see, I believe we're going to go with 6 because this thing showed up 6 there and it showed up 6 here. So I think this thing will show up for 6 now. There we go. Now he's got to get a good probability. That's 0.16. There it is. He got it. So he won his money back because that's 0.2. If he gets too much, he'll lose his money. Oops.
Well, we're making money now.
No, you done lost it again. No, I'm just kidding. Now, a while ago, somebody said something. I think Mr. Patel said, "Now it's going to hit 1." When he said probability of hitting 5, or one of the two. He said it's going to hit 5 when we were doing the probability of 1. Like the die knows what we're doing. What does the word inert mean? Huh? Oh, I'm sorry. That's not an SAT word, is it? Look it up. They didn't coach y'all to that?
Yeah.
Inert. I-N-E-R-T. What does that word mean?
It's not alive or doesn't
Exactly. Huh? Inanimate. Meaning that die doesn't know whether you picked a 5 or whether you picked a what? A 1 or whether you picked a 2. But why did it go from rolling all 3s to rolling all 6s to rolling all whatevers? And it rolled 6s again. Why? It's the way we perceive it. It's the way we see what we want it to do. It's going to be, if it does anything but what we want it to do, we think it's what? It's against us. And it's got feelings. It's just rolling the way it rolls, as the old saying goes. So what is very unpredictable? That die. Now, why do you think people go to Vegas? Why do you think people win money in Vegas? Because the probabilities are so low. Let me give you an example. I got 8 minutes already. Have I taken the roll yet? All right, I'll do that after this. What is the probability? We said the probability of finding, and it's the number of times something happens, this is probability, over the number of attempts. Now you have to think about this in context.
Inmate cards,
Okay, so we still got this computer, we're still going on this another if this was a deck of cards, 4 face cards, or not 4 face cards, 4 kings, probability of kings, picking a king, would be 4 over what? 52. If you lay all 52 cards on the desk, you're going to pick one of them, right? So how many attempts do you have? There's 52. You put the card back down, or somebody puts it in the deck and moves them around. How many attempts are left? 52. Pick one up, put it back down, mix them up. How many tries? 52. 52 does not change yet. All right? So the number of tries is 52. This probability comes out to be what? Somebody put it on the calculator. What did you say it was? Point? How much? 0.08. So you got an 8% chance at picking a face card. If I was to bet you $100, would you bet it? Why? Because the probability is so low. What does Vegas pay off of? Low probability. Because if they pay on low probability, they're not going to lose their money. If they pay on high probability, they're going to lose their money and go broke. There's 2 entities that do not believe in charity. The bank and Vegas. They don't believe in charity. And they're both about the same thing. Okay? Now, what is a high probability? Well, the probability of getting a number card. Well, 2, 3, 4, 5, 6, 7, 8, 9. So 9. 9 times 4 is what? 36 over 52. What is that? Huh? Yeah. 0.7. Where will this game be? This will be over there with the nickel slot machines over there in the kindergarten casino, where people don't want to lose any money. Why? Because Vegas ain't going to pay out hundreds of dollars on this probability. They're going to pay on this. Okay. Where do you stand to make more money at the racetrack? On the mule that's going to come in last, or the one that's got all the prizes? The mule that's going to come in last. If it's a 51 shot, and you bet $200 on that 51, what you going to break on, or what you going to get? Well, it's 50 times 20, or 5. What did I say? $200. 200 times 50. It's 10,000, right? So that's what. Versus if you bet on the one that's favored, it's 5 to 1. If you bet on 200 on 5 to 1, that's $1,000. If you bet on the one that's 50 to 1, that's like $10,000. Okay? All right, let me get the roll. We'll finish up probability introduction next week. Or when do y'all come back?
Monday.
Monday.